UPS, or uninterruptible power supply, is indeed considered a separately derived system as per the National Electrical Code, specifically Article 250.56. Because of this, the grounding and bonding must adhere to NEC Article 250.24. This section dictates that the system grounding conductor and the equipment grounding conductor must be bonded together at the service entrance or another suitable location where the system receives its supply. Now, regarding the separation of neutrals and grounds, NEC Article 250.24 mandates that the grounding electrode conductor, that's the one connected to the ground rod, and the neutral conductor be connected to a single terminal bar. However, the code does not explicitly state that the neutral and equipment grounding conductors, often identified as the green wires, must be on separate terminal bars. In the scenario presented, where the panel board has only one terminal bar, interconnecting the neutrals and equipment grounding conductors can be acceptable under certain conditions. Firstly, the panel board must be properly bonded to the UPS ground terminal or another suitable grounding electrode. Secondly, the UPS should be listed as having an isolated output. Thirdly, the equipment powered by the panel board must not require a specific grounding separation between the neutral and grounding conductors. If the equipment does require this separation, then the neutrals and grounds must be kept separate at the panel board. This is typically achieved by utilizing a panel board that has separate terminal bars designated for neutrals and grounds. It is strongly advised to reach out to the UPS manufacturer directly. They can provide specific grounding and bonding requirements that are tailored to your specific UPS model. Also, it is crucial to ensure that the installation complies with all local code requirements. It's important to clarify a few key concepts related to electrical grounding and bonding to fully understand the implications for UPS systems. Grounding refers to connecting electrical equipment to the earth, providing a lower impedance path for fault current to flow back to the source. This helps to trip over current protection devices, such as circuit breakers, quickly minimizing the risk of electrical shock and fire. Bonding, on the other hand, involves connecting all non-current carrying metallic parts of an electrical system together to create an electrically conductive path. This ensures that all these parts are at the same electrical potential, reducing the risk of electric shock. In a separately derived system, such as one powered by a UPS, the neutral conductor is intentionally grounded at the source, which in this case is the UPS. This creates a reference point for the electrical system and helps to stabilize the voltage. The equipment grounding conductor, which is the green wire, is connected to the metal enclosure of the equipment and to the grounding bus in the panel board. This provides a path for fault current to flow back to the source in the event of a ground fault. Now let's delve deeper into the NEC requirements for grounding and bonding separately derived systems. Article 250.30 covers the grounding and bonding requirements for separately derived systems. It specifies that a grounding electrode conductor must be used to connect the neutral conductor of the separately derived system to a grounding electrode, such as a ground rod or a metal water pipe. The size of the grounding electrode conductor is determined by Table 250.66 in the NEC based on the size of the ungrounded conductors of the separately derived system. Article 250.104 also requires that the metal enclosure of the separately derived system be bonded to the building's grounding electrode system. This can be achieved by connecting a bonding jumper from the enclosure to the building's grounding electrode conductor or to another suitable grounding electrode. It is essential to understand the difference between a system bonding jumper and a main bonding jumper. A system bonding jumper is used to connect the neutral conductor of a separately derived system to the equipment grounding conductors at the source of the separately derived system, which is the UPS. A main bonding jumper, on the other hand, is used to connect the neutral conductor to the equipment grounding conductors at the service entrance of a building. In the case of a UPS system, the system bonding jumper is installed at the UPS, while the main bonding jumper is installed at the main service panel. Now let's address the specific issue of interconnected neutrals and grounds in the panel board. As mentioned earlier, the NEC does not explicitly prohibit interconnecting neutrals and grounds in a panel board under certain conditions. However, it is crucial to understand the potential risks associated with this practice. When neutrals and grounds are interconnected, any current flowing on the neutral conductor will also flow on the equipment grounding conductors. This can create a voltage potential between the equipment grounding conductors and the earth, which can be a safety hazard. In addition, interconnected neutrals and grounds can create ground loops, which can cause noise and interference in sensitive electronic equipment. Therefore, it is generally recommended to keep neutrals and grounds separate in panel boards, especially when serving sensitive electronic equipment. This is typically achieved by using a panel board with separate terminal bars for neutrals and grounds. The neutral terminal bar is connected to the neutral conductor from the source, while the ground terminal bar is connected to the equipment grounding conductors. When selecting a panel board for a UPS system, it is important to choose one that is appropriately sized for the load. The panel board should have enough circuit breakers to accommodate all the equipment that will be powered by the UPS. It should also have a sufficient ampacity rating to handle the total load. In addition, it is important to choose a panel board that is listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories or all. This ensures that the panel board meets the applicable safety standards. When installing a UPS system, it is important to follow all the manufacturer's instructions and the applicable NEC requirements. The installation should be performed by a qualified electrician who is familiar with UPS systems and the NEC. Before energizing the UPS system, it is important to thoroughly inspect the installation to ensure that it is safe and compliant. This includes checking all the wiring connections, verifying the grounding and bonding, and testing the operation of the circuit breakers. Regular maintenance is also essential for UPS systems. This includes periodically inspecting the batteries, checking the wiring connections, and testing the operation of the UPS. It is also important to keep the UPS clean and free of dust and debris. In addition to the NEC requirements, there may be local codes or regulations that apply to UPS systems. It is important to check with the local authorities to ensure that the installation complies with all applicable requirements. Let's recap the key points to consider when grounding and bonding a UPS system. Firstly, a UPS is considered a separately derived system. Secondly, grounding and bonding must comply with NEC Article 250.30. Thirdly, a grounding electrode conductor must connect the neutral to a grounding electrode. Fourthly, the metal enclosure must be bonded to the building's grounding electrode system. Fifthly, interconnected neutrals and grounds can be acceptable under certain conditions. Sixthly, it is generally recommended to keep neutrals and grounds separate. Seventhly, choose an appropriately sized panel board. And eighthly, follow all manufacturer's instructions and NEC requirements. Furthermore, let's elaborate on the conditions under which interconnected neutrals and grounds might be acceptable and the rationale behind the recommendation to keep them separate. In certain specific scenarios, particularly in older installations or where the UPS manufacturer explicitly permits it for this specific model, interconnecting neutrals and grounds within the panel board might be considered acceptable. This is usually predicated on the UPS having an isolated output, meaning that the UPS isolates the output power from the input power, effectively creating a new clean source of power. The isolation transformer within the UPS plays a crucial role in this scenario. Additionally, the equipment being powered must not be sensitive to common mode noise, which can be exacerbated by interconnected neutrals and grounds. However, even in these scenarios, the potential drawbacks of interconnected neutrals and grounds often outweigh the perceived benefits. When neutrals and grounds are connected, any neutral current, which is the current returning to the source from the load, will also flow through the equipment grounding conductors. This can lead to several undesirable consequences. Firstly, it can create a voltage potential between the equipment grounding conductors and the earth, also known as ground potential rise. This voltage potential can be a safety hazard, as it can cause electric shock if a person comes into contact with both the equipment grounding conductors and a grounded object. Secondly, it can increase the risk of ground loops. A ground loop occurs when there are multiple paths for current to flow between two grounded points. This can create circulating currents in the grounding system, which can cause noise and interference in sensitive electronic equipment. Thirdly, it can compromise the effectiveness of surge protection devices. Surge protectors rely on a low impedance path to ground to divert surge currents away from sensitive equipment. When neutrals and grounds are interconnected, the impedance of the grounding path can increase, reducing the effectiveness of the surge protector. For these reasons, it is generally recommended to keep neutrals and grounds separate in panel boards, especially when serving sensitive electronic equipment such as computers, servers, and networking devices. Separating the neutrals and grounds ensures that the equipment grounding conductors provide a dedicated path for fault current to flow back to the source, minimizing the risk of electric shock and fire. It also reduces the risk of ground loops and improves the effectiveness of surge protection devices. When using a panel board with separate terminal bars for neutrals and grounds, it is important to ensure that the neutral conductor is properly insulated and isolated from the equipment grounding conductors. The neutral conductor should be connected to the neutral terminal bar, while the equipment grounding conductors should be connected to the ground terminal bar. The two terminal bars should not be connected together. In addition to the NEC requirements and best practices, it is also important to consider the specific recommendations of the UPS manufacturer. The manufacturer may have specific grounding and bonding requirements for their UPS model, which should be followed carefully. The manufacturer may also recommend specific types of panel boards and wiring configurations for use with their UPS. It is also important to consider the environmental conditions in which the UPS will be installed. If the UPS will be installed in a damp or wet location, it is important to use a panel board that is rated for wet locations. It is also important to use corrosion-resistant wiring and connectors. In addition, it is important to ensure that the UPS is properly ventilated to prevent overheating. Overheating can damage the UPS and reduce its lifespan. Finally, it is important to have the UPS system inspected and tested regularly by a qualified electrician. This will help to ensure that the system is operating safely and reliably. The electrician can also identify any potential problems and make recommendations for corrective action. In summary, grounding and bonding a UPS system is a critical aspect of electrical safety and system performance. By following the NEC requirements, best practices, and manufacturer's recommendations, you can ensure that your UPS system is properly grounded and bonded, minimizing the risk of electric shock, fire, and equipment damage. Remember to consult with a qualified electrician to ensure that your UPS system is installed and maintained properly. This explanation should offer a comprehensive understanding of the complexities involved in UPS system grounding and bonding. Always prioritize safety in compliance with applicable codes and standards.